The EDS31021 DPAT, or Digital Pulse Analyzer and Timer, does what no other ordinary frequency counter or combination unit like, for example, the B&K 1856 does. Except, of course, for the EDS52A, designed in 1984, which was limited to 4 digits and was quite large. Only 4 EDS52A units were made for internal use, and it was never marketed to the public. Like the EDS52A, the current DPAT was mainly designed to be used for hardware manipulation and mission-critical assembly coders needing accurate pulse and timing readings, along with frequency and pulse counting, requirements for anyone dealing with stepper motors, bionics, robotics, servos, digital signal streams, and so on. This first prototype is limited to 4 MHz, which is fine for the majority of mechanical motion control software engineering. As you can see, it's a little rough. It's the first prototype. The board was made on the LPKF Protomat 92S. You can see a little bit of a couple of chips hanging there from pieces of wire, but new board will be better, obviously. So this current EDS31021 DPAT display uses 8 bright red LED digits, and it's very small. It's only 5 inches wide, 1 inch high, and 2 inches deep. It runs from a 5-volt power source of less than 200 milliamps, measures frequency in 8 digits from 4 MHz down to 1 Hz with no gate switching, measures period with selectable high or low pulse width. So you can find that elusive positive or negative 10 microsecond pulse that occurs every 20 seconds. And it will hold the reading for as long as the longer resting period of the pulse lasts. It automatically resets at the beginning of the next pulse for a stable, non-blinking display. It also does timing. It will measure long times of a selectable high or low period from 1 microsecond to 99 seconds with the full 8-digit display with constant readout. The reading will hold until the polarity changes again to the resting pulse level. The fourth function is accumulation. The fourth function is accumulation. This is used mostly for making sure your stepper motor is receiving the exact number of pulses to travel a calculated distance. In this case, the readings will accumulate until you press the reset button. Pulses can be long as any length you want, or short as 1 microsecond. The readings remain on, and they're cumulative, so you can reset it whenever you need to. So you can see there's a set of buttons on the right-hand side. So right now it's on accumulation. This is the frequency mode, timing mode, and period mode. So I'm going to reset it. We're going to set it to look at either a negative part of the waveform or positive part of the waveform. Let's move this over a little bit so you can see the switch here. So the switch is on the right hand side. This is your function switch. This is your reset switch, and this is measure either the high part of the period or waveform or the low part. So right now we're going to set it for the high part, and we'll start off with accumulation. So what we're going to do, we're going to set the function generator. This will do nothing spectacular. Let's just go ahead and set it to put out, I don't know, say 10 Hertz. So let's hook it up. Now what you see is the red flashing light above the display is showing you the positive part of the waveform. I'm going to slow that down just so you can see what I mean. I'm going to slow it down to 1 Hertz. So you can see right now every time the part of the waveform becomes positive, that light lights up. And you can see the counting is counting up with every positive pulse. If I go ahead and I flip the switch down, now you can see that it counts every time the light turns off. So it's actually inverting the signal. So that's accumulation, and it'll just accumulate forever until you reset it. And you can accumulate, you can see as slow as you want, 1 pulse every day, or you can do accumulation at 4 megahertz if you wanted to, 4 million cycles. The counter actually will go all the way up to 99, but the maximum frequency that this one can handle, this particular prototype, is 4 megahertz. It's an early version. We'll change the chipset later on. Okay, so now the next function, we're going to go ahead, we'll push the function button, and we're putting it on frequency. So right now you can see it's 1 hertz. And on frequency, really doesn't make any difference. You measure the low or the high side. Frequency is frequency. But whatever, I'll put it on the high side because typically you're talking about TTL signals anyway, 0 to 5 volts. So there it's frequency. So it's measuring 1 hertz right now. Let's go ahead and set it for, is 1 kilohertz. Right on the money. You can see the decimal points. 3 on the right, microseconds. In the middle, milliseconds. And on the end, seconds, if you're measuring period. And frequency, it's hertz on the right, kilohertz in the middle, and megahertz on the left. So there's 1 kilohertz. There's 100 kilohertz. There's 2 megahertz just for ducks. So we're 55 cycles off. And whether it's my Chinese DDS function arbitrary waveform generator for $69 or whether crystal needs to be set, I don't know, but there is a setting on there for it. You can see a little adjustable capacitor there. Okay. Alright, so that's frequency. No big deal. Everyone can do frequency. We'll get to timing later on. We're going to go ahead and do period next. Okay, so now we're going to do period. Let's turn this frequency down. Period's typically measured, you want to measure microseconds or whatever, so let's go ahead and for waveform we're going to put it on pulse. And we're going to go ahead and set the frequency just for ducks for, let's see, I'm setting the frequency just for clarification to make it easy. I'm going to set it for 10 hertz. Oh, let's set it for 100 hertz. Okay, so there's the 100 hertz. I've programmed, if you can see the readout over here. I can hold it steady enough. You can see I set it for 10 microsecond pulses at 100 hertz. So, to clarify what that means, here's your 10 microseconds on the high side of the pulse. Which means the low side of the pulse is going to be the rest of the time, right? And there it is. 1 millisecond, which is 1,000 microseconds, is the remainder part of it. So that's the low end side of the pulse. 9 milliseconds, 9.999, whatever milliseconds. It shows 9.98, and of course the last one is flashing, a little fat, too quickly to read. And the high side of the pulse is your 10 microseconds. So I'm going to go ahead and set the pulse a little bit slower. Actually a quicker pulse, I should say. There's 5 microseconds. You can see it's flashing between 5 and 6. There's 100 microseconds. So of course that means the negative part of the pulse will have gone down a little bit. You can see it's down to 9.896 milliseconds. So again, that's the only machine that I know of other than my old EDS31021 from 35 years ago that can actually measure the individual parts of a pulse. And it'll also do it very quickly. You could have a 1 microsecond pulse every hour, and it'll catch it. All right, what's the last thing? The last function is timing. Okay, so with timing, that's if it's not a short pulse like this, it's a really long thing, like maybe you're setting something that, it's got to run for 10 seconds or something like that. Okay, so let's go ahead and set the pulse generator. Back to square wave again, and we're going to set the frequency this time for 10 seconds. Let's see. Okay, 10 seconds. So let's go ahead and put it on the time mode. Okay, now at this point, let it reset one time. Okay, you can see now what it's doing. It's counting up, and this time it's keeping the display on all the time for you to see what's going on. Now we did set it for, let's see, 0.0001 hertz, which is obviously 1/10 of a hertz. But remember, you're measuring just the high part of the wave right now, so that's why you're showing 5 seconds. It's 10 seconds, but it's going to be 5 seconds high and 5 seconds low. So that's how, if the pulse is going high and low, you can see that would be the high end of the pulse. And here's the low end of the pulse. Let it reset one more time, and now of course it should be even, assuming I've got a decent square wave here. And there it is, 5 seconds, within 128 microseconds, give or take. So that's your timing. And what's interesting about this, let me get out of the screen here. Oh, it doesn't let me change it while I'm recording video? Okay, I didn't know that. Alright, so what I'm doing here is I'm just disconnecting the input altogether. So now what's doing now, of course it's the low side of the pulse, it's just going to count forever because there's nothing hooked up to it. And there's the high side of the pulse. So if you just want to use it just as a generic timer, you can do that. You can go ahead and reset it, put it over the timing mode, and then, you know, there you go. There's a real handy egg timer. Alright, so that's basically it. So you got your different functions. It's your timing function, you got your period, you got your accumulation, and frequency. And that's pretty much it.